Yes, class. So in the last class, we had completed particles velocity, particles acceleration, and waves velocity. We have to start with superposition principle. So basically, superposition principle, this principle is not just for your class 11th, in your class 12th also this principle will be used. We'll be doing you will be doing electrostatics. So there, here displacement of the wave is given. There, that time you'll be having electric field, you'll be having electric force. So principle remains the same. Principle basically says that whenever more than a single quantity is present, then how will you get the resultant? So here we are specifically talking about the displacement of the wave. So let's talk about the displacement only. If I want to calculate so many displacements of these waves, so what will I do? I'll just add all these waves vectorically. The point that you have to remember, this is not algebraic addition, that 1 plus 1 plus 1 plus 1 like I'll be adding. These are all vector addition because we know displacement is a vector quantity. So when two or more waves pass through the same medium at the same time, net displacement at any point is the vector sum of their individual displacements at that point. Means calculate the individual displacement and then get the value. Write it down. Then we'll start with interference. See, when we are starting with interference, you have to understand what interference is a part of. So it's an extension of superposition principle only. In superposition principle, what did I tell you? Different waves are coming. So in interference, when we are talking about superposition, that is imposition of two waves will be occurring. So in interference, when I'm saying superposition principle, two or more waves will be superimposing on each other. That is what is meant by superposition principle. This is the interference. Second is stationary waves. So you have two types of stationary waves, longitudinal and transverse, that we'll be doing, and then you have the beats. So here we are starting with the interference. Just make this flow chart, then I'll start with interference. Okay, class, starting with interference. So interference is basically superposition of waves, but the condition is that their frequency and the wavelength, both these things should be the same. If I'm saying this is one wave y1, its frequency, its wavelength, and I'm saying there is one more wave y2, its frequency and wavelength, they should match each other. Now when y1 will be kept on y2, suppose this is y1, this is y2. Now the new wave that has been formed, this new wave that has been formed, this is the interference of waves that have occurred. This is what we call as the interference. So let's say first equation is a sine omega t minus kx. Second equation is b sine omega t minus kx plus phi naught. Why phi naught? Because phi naught is just this additional phase difference that is coming between the waves. Can you see both the waves are having a phase difference? That phase difference itself. All right. So y is equal to y1 plus y2. So y is equal to r sine omega t minus kx plus delta. This is the resultant that we have taken. So r is the amplitude of the resultant wave. All right. And when we are talking about this delta, this is the amplitude of the resultant phase constant. See, one initial phase constant is present, but then when the waves have superimposed on each other, a new wave has also resulted itself. So this is the same wave. Understood? So how do we write this? How do you calculate this? How do you calculate this? So resultant amplitude, whenever you have to calculate this resultant amplitude of the wave, take the amplitude of the first wave, square it. Take the amplitude of the second wave, square it. Plus 2ab cos phi under root. And when we are calculating tan phi, it's just like the parallelogram law. B sin phi by a plus b cos phi. This is how you will get the resultant amplitudes equation, the value magnitude of it, as well as the direction, because it's a vector quantity. So this part will be giving you the magnitude. This part will give you the direction. So you have the direction as well as the magnitude because it's a vector quantity. That's intensity. Just remember, see, intensity of the resultant wave. Intensity I1 is equal to Ka square. Intensity 2 is Kb square. Why? Because intensity is directly proportional to square of the amplitude. That's why. But when we are talking about the resultant intensity, the resultant intensity is written as I1 plus I2 plus 2 root I1 I2 cos phi. This is how the resultant intensity is written. Write down all these things. Okay, now interferences are also of two types. You have constructive interference and you have destructive interference. For that, you should have a basic idea about the waves. I have already started with the waves terminologies, that's why. That's why I started with the waves terminologies. I told you what is a wavelength, what is one time period, and I also told you about the amplitude, right? This is the amplitude, maximum displacement from the mean position. Then we talked about the crest and the trough, right? So when we have the constructive interference, in constructive interference, one wave's crest combines with another wave's crest and results in a greater amplitude. That is A plus B. This is the maximum one. So angles which are possible 0, 2 pi, 4 pi, like this. So phi is equal to 2n pi. This is the formula. N is equal to 0, 1, 2, 3, and so on. And when we are talking about the resultant intensity, this is written as under root I1 plus under root I2 whole square. Whereas when we talk about destructive interference, here crest and crest coincide or trough and trough coincide. In constructive interference, you have two combinations. Crest plus crest or trough plus trough. But when we are talking about destructive interference, you only have one combination. For destructive interference, crest and trough will always combine of one wave. If crest of this wave, trough of this. If trough of this, crest of this, like this. And it decreases the amplitude because it is subtracting in opposite direction. So here amplitude will be minimum, that is A minus B. So you get the minimum intensity of the wave under root I1 minus root I2 whole square. And we are talking about the angle. This is pi because this is 0 degree. So, minus 1. So 3 pi, 5 pi, 7 pi, all the odd values. So it's better if you directly write this as 2n minus 1 into pi. Now we'll be using this and then we'll be solving the questions. I think after this you have the question, we'll do this. Write it down. two superimposing waves are represented by y1 is equal to 2 sine 2 pi 10 t minus 0.4x. y2 is equal to 4 sine 2 pi 10 t minus 0.4x. I'll give you time to write it down. Right now, don't write it. See, we have to find out the ratio of I maximum to I minimum. First thing, what is I1? I have told you intensity is directly proportional to square of amplitude. So I1 will be, let's say this is I is equal to K A square. So this will be equal to K first square. So I1 is equal to 4K. Similarly, when we are talking about this becomes 4 square because the amplitude here is 4. Here it was 2, here it's 4. So this implies that second is equal to 16K. Now at least we have the values, we can further calculate it. So when we are talking about the maximum, under root I1 plus root I2 whole square, this is equal to under root 4K plus 16K root whole square, which is equal to 2 root K plus 4 root K whole square, which is equal to 6 root K whole square. This is equal to 36K. This is the maximum one. When we are calculating the minimum one, that is root I1 minus root I2. Why? Because this is a part of destructive interference. So this becomes 2 root K because 4 was already there, minus 4 root K whole square. That is equal to 4K. So when we take the ratio of I maximum to I minimum, we get 36K by 4K. No need to reduce it because the final ratio for us is equal to 36 is to 4. Why am I saying do not reduce reduce this? Because in this question, options are already given. You people have not written the question. That's why you must not be knowing this. See here. So if we reduce this, this will be wrong because there is no other option such as 9 is to 1, right? So first option. Note down this question and the solution. Any doubts if you have, let me know from this. This question is clear to you. Just use the equation I is equal to Ka square because intensity is directly proportional to square of amplitude. See, starting with the interference is completed. Now we will move to standing waves or stationary waves. So when the amplitude here will also be the same, here frequency will also be the same. Just the difference that will come is that the waves should move in the opposite direction. They should superimpose to give the standing wave. Understood? Energy remains confined in a region. See, firstly, if I tell you this is the incident wave, all right, if this is the incident wave, this direction will be something, and this is the reflected wave. This is the reflected wave. So if we take this direction as positive of the incident wave, direction of reflected wave will be negative. So firstly, when we are talking about the wave, suppose this is a stationary wave that has been formed because of superimposition of different waves with the same amplitude, same frequency, and moving in opposite direction. These points, cut points which intersect, these are called the nodes. And these points which do not intersect, high amplitude points, these are called the antinodes. I'll tell you this later also. Now see, if this is incident wave, this is the reflected wave. So incident wave will be a sine omega t minus kx. Reflected wave will be a sine omega t plus kx. So incident plus reflected is equal to the resultant. Y is equal to a sine omega t minus kx plus a sine omega t plus kx. So y resultant intensity becomes 2a cos kx sine omega t. Two a cos kx sine omega t. This is the equation of the stationary wave. This is the equation of the stationary wave. All right. So amplitude of the resulting stationary wave, this is written as 2 resultant, this is written as 2a cos kx. Because anything apart from sine theta becomes your amplitude. So this entire term is the amplitude. Now see, points of zero amplitude means the points of node. So it means where your R is 0. Resultant amplitude is 0. So 2a cos kx will be 0. Cos kx will be 0. Means your cos theta is 0 degree. That is theta is equal to 90 degree, or you can say theta is equal to pi by 2. So what are the values that we'll get? K will be pi by 2 or 3 pi by 2, or this will be 5 pi by 2. So best way to write it in concise manner is 2n minus 1 pi by 2, like this. When we are talking about it, see, n is what? N is any number. 1, 2, 3, 4, 5, 6, up till any number. See, I already told you a relation also between the wavelength. So see, if k is equal to 2 pi by lambda, and k is this also, it means I can equate both of these. 2 pi by lambda, I can equate it with 2n minus 1 pi by 2. So pi will be cancelled. From here, here x will also come. Kx, no? Kx. This is equal to kx. So from here, x will be equal to 2n minus 1 lambda by 4. Now, this is the formula of x. X is equal to 2n minus 1 lambda by 4. So if you start putting the value, n is equal to 1. So x1 will be equal to lambda by 4. How? 2n minus 1. That is 2 into 1, that is 2. 2 minus 1 is 1. So you have 1 lambda by 4, that is lambda by 4. When you put n is equal to 2, that is the second node, you get 2 into 2 minus 1 by 4 lambda, that is 3 lambda by, like this, you will get. But if you take the antinodes, that is the points of highest or maximum amplitude, that is cos theta will be 1, theta will be 0. So this time you get 0, pi, 2 pi. So you have the main formula as n pi. In the previous part, you had 2n minus 1 lambda by 2. This is simply n pi. So 2 pi x, here again we are equating, this is k into x is equal to, this is also kx. You just get x is equal to n lambda by 2. So you have to understand if the question is asking antinodes or nodes. Start writing quickly. This question says y is equal to 6 sine 2 pi x by 6 cos 160 pi t. You have to find out the frequency, amplitude, wavelength of the original progressive wave and the equation of the original progressive wave. So see, if y is equal to 2a sine kx cos omega t. So we'll equate it with the main equation, with the equation that is given, that is 6 sine. Look, everything is coming under one another. 6 sine 2 pi x by 6 cos 160 pi t. So we know what all things are mentioned already. So omega is equal to 160 pi. We have to find out linear frequency. Omega is equal to 2 pi nu. So linear frequency will be equal to omega divided by 2 pi. That is, linear frequency will be equal to 160 pi, which is equal to 2 pi nu. So pi. So frequency will be equal to 80 hertz. Clear class? This formula is very important. Using this, you can calculate frequency and you can keep on converting it. One more thing, see, 2a is given as 6. It means amplitude is given as 3 centimeters, half of it. This is also done. And lastly, lambda is left. So see, k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k. So if you equate, k is given as 2 pi by 6. So lambda is equal to 6 centimeters. When you have to write down the entire wave, y is equal to 2 sine kx cos omega t. So y, you can write it as a sine 2 pi by 6 plus 160 pi p meters. Like this, you have to write down the entire equation. Write it down. See, if we talk about standing wave in a string, like the strings of guitar, so the difference that will come is here this will be the same. The angle will be pi. This will be fixed. So if you write the equation A sine omega t minus kx minus A sine omega t minus kx. So when you use this identity, sine A plus B minus sine A minus B, if you use this identity, this is equal to minus 2 cos A sine B. So if we substitute this in our equation, y will be equal to minus 2A cos omega t sine kx. Again, we'll have the same amplitude, same conditions. If we take this as 0, we'll again have 2L 2 pi till n pi. So lambda will be equal to 2n by n. One thing, this relation is also there. See, velocity is equal to frequency multiplied to the wavelength. So if you have to calculate the frequency, it will be equal to velocity by wavelength. So when you substitute wavelength as 2L by n, frequency will be Vn by 2L, where n will be 1, 2, 3, 4, and so on. Write this down as well for the string. Okay, class, you can complete, if you have completed, you can leave. Now, from the next class onwards, we are left with speed of waves, organ pipe, and Doppler, these three. Next class, we'll complete waves. The last class of waves will be on Thursday. Okay, class, you can leave now. Thank you so much.